Right, welcome back. So today we are in week 3, and this is 26th of January, 2022, Wednesday. And in this lecture, I would talk about lab 1, the first lab, and we are going to do question 3.4 and 3.5 in some details. So the purpose of this 1 hour long recording is to discuss these questions in greater details. Okay, but before I do that, I know that some students have questions regarding the tutorials. So in the tutorials, what I'm going to suggest you do is this. For tutorial 1, what you need to do is you would have this zip file, and in this zip file for the tutorial, you would have this Word document called CE3007 Tutorial Video Link 2019. Now, if you click into this link, you will see that in 2019, I also conducted this course. So this is about 3 years ago now. And you'll see that during this time, I also recorded various questions for different tutorials. For example, on the 17th of January 2019, I did question 1 for tutorial 1. You can press on this link. Now, if it breaks, I'm going to show you another way to do it. And on week 2, I did question 1, question 2 to 6. And on this 24th of January, question 7 to 10. Now, if this breaks, what should you do? So we go to 24th of January 2019, where we go to our course website, and 24th of January 2019 is in 18S2. So we'll go to 24th of January, which is here, and then we just click on this link. So you can go then jump to the different places, and you would get the answers where I discuss all this. So because the recordings are there, and I have given enough details here, you can find the information you might want for different tutorials. Okay, so if you follow this schedule, of course, you change 2019 to 2022, then you'll be very, very close to our speed. Right? So you realize that in the past years, I've discussed all this in great details already, and I'm not going to repeat them. Instead, I will use this time slot to answer any questions that you may have, in particular regarding the lab or different questions of the tutorials which I've not explained or that remains unclear. Okay, so I'll stop. Right, so let's come back to our lab. Before that, I'll pause and ask any questions. Right, so in lab 1, question 3.4, the question asks you to write a Python program. Actually, the Python program is not important. You can write in C, C++, MATLAB, anything you want. It doesn't matter. If you write Python, you can write in Jupyter Notebook, which is fine. During the lab, please bring your own laptop so that you do not need to use our school's desktop. And therefore, the environment will have been what you have been used to. So you just bring your own laptop, go to the lab, do the questions. Okay, the only thing we ask you not to do during the lab is to communicate with anyone else who can give you answers. What we need you to do is to do the lab by yourself. Now you can Google and stuff like that, but you cannot be WhatsApping your friend to get the answers. That's not, yeah, that would be cheating. And if you are found cheating, then you know all the consequences. All right. So the first thing we are asked to do is that we are given an equation like this. And let's see the equation. N is discrete. And what it implies is that N would typically be from minus infinity to infinity and integer. So sometimes we are lazy. We just use N equals to 0, 1, 2. That means we are only interested in the current time 0 to future values, positive integers. Now, you realize that this is the complex exponential and it is scaled by an. What is a? A is a real number. In this example, I'm going to ask you to plot with 0.95. And but you realize that in the quiz, I will give you another number, 0.98, 0.99, 1, and so on and so forth. And I also give you another number in the quiz. In this case, it's 2 pi divided by 36 radian per sample for the angular frequency, the digital angular frequency. In the quiz, I'll give you 2 pi divided by 16, 2 pi divided by 8, and things like that. And you are going to answer the question. Okay, that's the idea. All right, so I'm going to ask you to plot. So there are two parts to the plot. Of course, when you plot it, you will plot a single, you plot n, you plot 0, 1, 2, 3, and so on. So typically, we only ask you to plot the positive values like here. And then we're going to ask you to plot yn. Now, sometimes I make the mistake, I put curly bracket, it's just syntax and it's not going to get into trouble, right? But if you really want to be very pedantic, then y square bracket n for integer, okay? And then you say n belongs to the positive integer. Now, I'm going to ask you to plot this, plot 2D plot of the real and the imaginary values on the same figure. So you realize that I'm going to ask you to plot two lines. One is the real line, and then one is the imaginary line. So maybe the real line would look like this. Later on, you will see that it will look more like, maybe I should use a blue. And you look like this, for example. And then the imaginary line would look like, well, if it is the same place, then you'll look like this, for example. Yeah. And so on and so forth. Now, this is the stem plot. The stem plot. Stem plot means this is one straight line with a circle there. Okay, I'm going to show you what my answer is now for this question. A equals to 0.95, omega equals to 2 pi over 6, 36. All right, so let's open up the spider. And already I'm going to plot 2 pi divided by 36. Okay, so k is 1. Later on, you'll realize, yeah, okay, let's throw away the k first so that I don't confuse you. So I'm sending 2 pi over 36. I'm sending, how many samples I need? I'm sending, I guess, it didn't say, huh? Well, let's send 36 samples. Or 72 samples. Okay, and the amplitude of A is 0.95. So if I really want to be very strict, I should be doing this. A equals to 0.95, omega equals to 2 times numpy dot pi divided by 36.0, and then I send omega. Okay, so in fact, that's how you should write your code, right? So that you do not need to remember the parameters. Okay, all right. Let's see what we do, and then let's see what we get. So this is the variable, this is the function, and the function is on top. And now we see the function. The first parameter is number of samples. And then we have A and W. Right? W is the, what do you call that? Digital angular frequency. Let's run. Okay. What's my mistake? I always have this kind of errors. No idea what's happening. What is my mistake? Okay. Now, so let's plot. Let's plot A first, a to the power of n. If a, so a to the power of n, a is 0.95. The first value is 0.95 to the power of 0. 0.95 to the power of 0 is 1. The second value is 0.95, 0.95 squared, and so on. Oh, let's zoom in. Instead of plotting 80 numbers, let's plot, let's say, 5 numbers first. And let's see the 0.95. So the first number is 0.95 to the power of 1. The second number is 0.95, 0.95 squared. So it's coming down. Okay, so we can see the numbers. All right, then now let's plot 50 values and let's take a look. Okay, so we have these nice figures going there. All right, now then I want to plot the real and the imaginary. Where's my real and imaginary? I think I better remove some of these figures. So when I want to plot my real and imaginary, to remove. I'm going to now show you this plot. The red one is the real and the green one is the imaginary. So I'm going to plot this. I'm going to remove these guys and let's going to plot the second guy. So you'll see the red one is the real and the green one is the imaginary. Now you'll be asking yourself, why does the curve goes down? And the curve goes down because of this AN. Okay, so let's study these two figures again. Where's the equation? So let's bring up. Okay, so I'm going to study this equation in slightly more detail. Okay, so let's create a new page. And let's create a plus. And we are going to have a new page. All right, I'm just going to use the lab and find a space here. Okay, so y of n equals to a to the power of n e j omega n plus v. And we're going to write down the equation fully. 0.95 n e j omega is, let's remember what omega is, 2 pi divided by 36n plus v0. Okay, let's check. Now, what you need to do is you go into the table and you plot for the a to the power of n. So 0, so 0.95 to the power of 0 is equals to 1. The second value is 0.95 to the power of 1 is 0.95. The third value is 0.95 to the power squared, whatever value you calculate out, okay? And so on. So AN is very easy to find. What about EJ theta, okay? So we consider this as theta. And remember, this is the Euler's formula. So EJ theta is equals to cos theta plus J sine theta. Now, what is theta? Remember, theta is this whole thing here. Now, we're going to put this whole thing as theta. Okay, E, J, then, well, we have only 2 pi over 36n. So the only thing that is happening is n. All right, never mind. So it's cosine, cosine, pi over, well, 2 over 36 is 18, n. Now put the bracket correctly so you won't be confused. plus j sine pi over 18n. Now let's substitute with different n. So the first n equals to n, in this case will be equals to 0 first. So we have cosine pi over 18n. What is this value? It is cosine 0. Cosine 0 is 1. Their second guy is sine pi over 18n. At n equals to 0, so it's sine of 0. Sine of 0 equals to 0. So the first value is 1 plus j 0. So this is e j omega n. Okay, so we can then now put our e j 2 pi over 36n as the first value is 1 plus j 0. Now, this is the real part and this is the imaginary part. So let us see the figure that we have plotted. The first guy is, the red one is the real, the green guy is the imaginary. So real is 1, imaginary is 0. All right, I'm just going to do a few more examples. So let us only see 5 values so that we won't be confused. And then let's plot. Okay, the second value. What value is this guy? So it's like n equals to 1. Let's try. Okay, so let's go to our, so manually 1, n equals to 1. So basically this is cosine pi over 18. And this is sine pi over 18 equals to, so I'm going to use my MATLAB and go and calculate. Okay, so cosine pi divided by 18, it is 0.984. And what about sine? Sine pi over 18, which is 0.17. So what have I just done? I have filled up 0.98 and 0.17. Now you go and look at the tape, the figure again. This is like 0.98 and this looks like 0.17. Now, if of course, if we do not believe that we get it right, so I'm going to train it. 0.9. Oops, did I make a mistake? I know why I make a mistake. Okay. Okay. Now, because I'm showing you the number after multiplying by a to the power of n. So I'm going to now cheat and I'm going to set a to 1 first. And then I'm going to plot the values 0.98, 0.17. So the complex exponential is correct, but the a to the power of n is wrong. So let's insert back our a, which is 0.95, right? And then we run it again. So we realize that the value has changed because this value is 0.95 times the complex exponential. Okay, so now we're fine again. So let's try and write my equation. So this is 0.98 plus j 0.17. Now finally, we finish the full computation of this guy, which is an times ej 2 pi over 36n, which is nothing but 1 times 1 plus j0. This is 1 plus j0. What about this guy? This guy is 0.95, which is a to the power 1 times 0.98 plus j 0.17. And the answer is, so 0.95 times 0.98, let's go and count. 0.95 times 0.98 is 0.93. And the other guy, so in the lab, I'm only interested in up to 2 or 3 decimal places, okay? And 0.17, the answer is 0.165. Now let's check again with our Python code. And spider is up. So it's 0.93 and 0.165. Cool, we got the answer. So I pause now and take any questions. Right, so basically you'll see that I I have by brute force computed this equation using a table and filling up the table. If you write Python, it's done in like 5 lines, right? So let's see the 5 line of code. So this is the 5 line of code, 6 lines. First set the array, and you can, of course the trick is this equation, the numpy a to the power of n multiply. You must use numpy dot multiply, and then the complex exponential here. Okay, and then we plot. All right, so I have just plot for you a to the power of n as well as the complex and the real. Let's proceed. What else do we want to plot? So the second thing in the question he asks us to plot is the polar plot of the sequence. Okay, the polar plot of the sequence. So this is the polar plot of the sequence. We have how many points? 1, 2, 3, 4, 5 points. Remember, the first point is real is 1, imaginary is 0, which is that little blue line here. Along this horizontal axis, this is the real axis. The middle of the circle is the origin, 0, 0. 0 real, 0 imaginary. The vertical axis is the imaginary line. The circle is a unit length. So at 90 degrees, this is plus j. This is 1. This is plus j. This is minus 1. And this is minus j. You make one round, you make 2 pi or 360 degrees. Let us see how to plot this red and the green as a phasor. So this is the phasor. So let us now focus on this. Let us see these 5 points, 1, 2, 3, 4, 5, as the phasor. The phasor is this blue, orange, green, red, blue, and it's becoming smaller. Why is the blue phasor this guy? Because the first point is y0, which is 1 plus j0. This is along the horizontal axis, this is 1. The imaginary axis is 0. So this is 1 plus 0. In the second point, it is 0.9 something plus 0.16 something or here. So 0.9 something, and then imaginary goes up a little bit. Okay, the third point is here. So the real has become smaller. So you see it shrinks. The imaginary has become larger, therefore it goes up. So in your eyes, as the n is going from 0 to 1 to 2 to 3 to 4, the phasor is rotating anti-clockwise and becoming smaller. Okay, so this is how we interpret. So this is the 2D plot. And where is the 2D plot? In the plot 2D, this is how you write the code. Okay, I've already given you the code. So you go and play with this. This is how you plot the phasor, the polar plot. Finally, the last figure shows you how to plot the complex plane. Okay, so this needs a little bit of interpretation. Let us go from here to here. Now, is there any way to drag this picture up? Unfortunately, there's none. Oops. Can I make the figure bigger? Okay. All right, let us study the relationship between the polar plot and the 3D plot. In the polar plot, there is no time. Time is seen by one phasor going to the next phasor, going to the next phasor, but you cannot see time here. Where is time? Time is, you are looking into this round thing, circle thing, and time is coming up to you. Okay, so you cannot see time. So instead, we now move this 2D plot slightly so that now time is here along this axis. The real is along this axis, and the imaginary is along this axis. Let us see where the first point is. The first point is along the real line 1, imaginary 0. The second one is real a little bit higher, sorry, a little bit lower, 0.95. How many? 95, I think. That's it. 0.93, sorry, 0.93, and imaginary 0.165. The third point is here, the fourth point is here, the fifth point is here. So now you can see that this is something is rotating a long time. Now it's not very nice to see because there's not enough points for you. So now let me increase the number of points from 5 to 10. Okay, so you will make a few observations. The first observation you'll make is the phaser will rotate more to the left, anti-clockwise. And this phaser will start to rotate and we have more samples to see a long time. Let's see. So first real, now we have 10 points from 0.0 to 0.9. We plot the phasers. Ooh, it's nice. It's going anti-clockwise and becoming smaller. Now we can see it moving. Well, it haven't even moved a circle yet. So in the quiz, the questions will be, how many points to make one period? Guys, if you look at this question, how many points? You see 36 here. I'm going to give you 36, and you'll realize that he is going to make one round. In fact, if I give you 34, he's going to almost make one round. Okay, let's see. So he's going to make almost one round. All right. See, he's almost going to make one round. Not yet, but you can see, oh, the phaser is rotating. Okay. So if I give you 38 or 36, he's going to make one complete round. See, the next point would hit 0. So he has made one complete round. And then if I give you 72, he's going to make 2 complete rounds. The green is making one round here. And then one more round here. Can you see? It's rotating. But then you say, hey, the guy is becoming smaller, so I cannot see. So instead of that, I'm going to give you 0. Well, let's try 1 first. That means the phaser will not decay. Okay, so the quiz questions are, what happened when the value of A is 1? What happened when the value of A is 0.99, 0.95, and things like that. So you see A is 1, means our phaser, our real and complex number does not decay. So we're moving around in a circle and it does not decay. See, we're moving one circle followed by another circle against time. So now you see that because I use 72 samples and omega is 2 pi over 36, therefore I know I will make 2 rounds. Okay, so the quiz question is, how many rounds would this guy make? So okay, it's 2. Right, now some of you would like to see that the circle is really spinning. So the trick is I'm going to use 0.98. So it is a smaller value than 1. So therefore, my cosine will become smaller and smaller. Let's see. Okay, so you see? So you see, the first round, and then the second round. First round, and then the second round. Of course, by changing the different value, you can appreciate this diagram even more. The first round, followed by the second round. Can you see? And because I use 0.99, it doesn't decay so fast. So you can see that it is like spinning and becoming smaller and smaller. And all right, now I'm going to animate. I'm going to animate this. Okay, so I'm going to show you this. So this figure is the 2D plot. As he is running, I'm showing you the 3D plot that is running at the same time. And then the real part and the imaginary part. So you see, the real part is running across time and the imaginary part is running. When I have this, I can plot the 2D. So he's spinning anti-clockwise because, so the quiz questions will be, is the complex exponential spinning anti-clockwise or clockwise? Okay, so this is very nice. And And you guys can figure out how to draw these three diagrams by yourself now. Okay, so now I would take questions. So the student asks, how do I know whether the thing is spinning anti-clockwise or clockwise? Can you see? Okay, I'm going to plot for you only 3 points. Okay? N equals to 3 points. I'm going to run this code. The blue one is the first point, right? The orange is the second point. Y0, Y1, Y2. Agree? Yes? No? Do you agree? Yes? So I'm now going to plot the 4th point. Can you see the red point? Yes?
Yep.
Is the phasor rotating clockwise or anti-clockwise?
Yeah.
Sorry?
Anti.
Anti-clockwise, correct. So how do I make the phasor move clockwise? Can you see I put a minus here?
Oh,
Yeah?
okay.
So now, when I plot, can you see he's moving clockwise? Now I'm going to plot 4 samples. I'm going to plot the 10th sample, okay? Can you see? He's moving what? Clockwise. Can you see now?
Yeah.
So did I answer what is clockwise and anti-clockwise from the polar plot?
Yeah, can.
Okay, great. Thank you. Any other questions, guys? I'll pause recording. Anybody? This is the last time I will talk about lab 1. Okay, so if there's any questions now, please raise your hand. Anyone? So in question 3.5, in question 3.5, I have just explained and show you different K and explain the relationships of K and the number of cycles and angular frequencies. Here, it might be clear to you now, the angular frequency is this. When K equals to 4, I'm moving by pi over 2. K equals to 3, I'm moving by pi over, then you can count. K equals to 2, I'm moving by, so on and so forth. Okay? All right. Any other things, guys? K equals to 1. Okay. Right. If you all have no more questions, I'm going to pause now. Then I think that's it. So the student asks, so you ask how to interpret this, right? So let us see the equations very carefully here. So omega n, right? What is omega n? Is 2 pi over n times k, right? So when k equals to 1, so let us try k equals to, let's say, how many again? 32, is it this kind? 16. Okay, let's try n equals to 16, agree? And k equals to 1. So which is 2 pi divided by 16 times 1. How many is this? Pi over 8. So we are making pi over 8 radian per sample. Agree? What is pi over 8? How many degrees is pi over 8? So pi divided by 8 times 360 divided by 2 pi. How many? 22.5 degrees. So we are making 22.5 degrees each sample. All right, what about n equals to 16, but k equals to 2, what happened? So it's 2 pi over 16 times 2, right? Agree? So this is pi over 4. Pi over 4? Now guess. So in fact, instead it's just double, right? So it becomes 45 degrees. So what about k equals to 3? 2 pi divided by 16 times 3 equals to, this is a bit harder. So 6 divided by 16, 6 divided by 16 times pi. So this is the radian, then times 360 divided by 2 divided by 2 times pi. And this is equals to 67.5 degrees. So every time I'm moving up, how many degrees am I moving? So this is 6 over 16 pi radian per sample. You realize that I'm moving 22.5 degrees. I'm moving faster by 22.5 degrees as I increase K. Can you see? From here, originally, I was moving 22.5 degrees at each step. If I increase the K by 1, I'm moving by 45. If I increase by K by 1 more, it's so where is this 22.5? Let us see the figure. All right, let's try. K equals to 1. Let us see where is 22.5 degrees. This point to this point, the first point to the second point is 22.5. So I'm going to use less samples to show you. This point to this point is 22.5. This point to this point is 22.5. So that's why in 2 points, I will make 45 degrees. In 4 points, I'll make 90 degrees. Okay. What about K equals to 2? I told you that now at each point, I'm going to move by 45 degrees. See, each point, I'm moving by 45 degrees. Okay, what about K equals to 3? Each point, I'm going to move by 67.5 degrees. From here, 67.5. 67.5 times 2, 135. Can you see now? Did I answer your question?
Yeah.
Okay. So now you also understand the idea of radian per sample. So as I increase my K, I am moving faster along the circle. Okay. All right. When would I move? How fast? Okay. So I'm going to increase. So you're going to see something very strange happening. I'm going to increase K equals to 4. So I'm now moving by 90 degrees. What happens if I move by K equals to 16? So that's a quiz question, for example. Then you say I didn't move a thing, right? But I did actually. Each step, I'm moving by 2 pi. Can you see now? Yes? You can you see that I'm moving actually by 2 pi? So in fact, it's a one straight line. Okay. All right. I'll take some more questions now. So in summary, today, on 26th of January, 2022, we did questions 3.4 and 3.5 in great details. And you can see the examples of Python and you can try it by yourself. In the quiz, what we'll do is this. We'll change different numbers, different case, and ask you to interpret things like whether it moves clockwise, anti-clockwise, stationary, random, what will A do, what will W do, and stuff like that. Okay, that's how we do. We work. And honestly, if you can answer all these lab questions, you can answer the quiz question anytime. Okay. All right, great. Thank you very much. And yeah, if I don't see you, or I'll see you on Friday again. And yeah, so if you have any questions, please send me an email. I repeat, if you need to see the tutorials, since I have done my tutorials and my recordings in 2019 for different parts, like tutorial 1, question 7 to 10, I'm not going to repeat. You can watch it in this video in January 2019. And where do you watch this video? It is, again, go to your adventure site, go to 18S2, and then you can see the 24th of January 2019. All the 2019s are here, and I think it is working. Okay, so you have no problem there. Okay, you can see all this. All right, with that, thank you very much. Have a good lunch. Thank you. Goodbye. Thank you all.